Hey there, hi there, ho there. This is What's Up with Giancarlo. So today we've got 16.3 box plots. Okay? Box plots can be a little tough, okay? A little tricky. There's a lot to go over. So everybody be ready to take notes, okay? Let's get it started with using a box plot. A box plot is a display that shows how the values in a data set are distributed or spread out, okay? To make a box plot, first find 5 values for the data set. Okay, so the least value is very easy. It's just the smallest number. Okay, the greatest value, very easy also, biggest number. Okay, so the median, easy. It's the median of all the numbers. Median of all numbers. So that's not a comma, that's this. Median of all numbers. So the lower quartile and the upper quartile are a little harder to find, but not that much harder. They are the median of the lower half of the data and the median of the upper half of the data. Okay? So if I've got 1, 2, 3, 4, 5, 6, 7. Okay, we'll say 7. Okay? If I've got 7, this is my first half, this is my second half. 4, okay. So 1 is the least value, LV. Okay? 7 is my greatest value, GV. 4 would be my median, M. And then 2 would be my LQ, my lower quartile. And then 6 would be my UQ, upper quartile. Okay? That's pretty easy. Okay? Right? Is it easy enough? Looks pretty easy to me, class. Okay. So, least value, smallest number. Median, median of all numbers. Greatest value, biggest number. The lower quartile and the upper quartile are the only things that you guys might have a problem with. The lower quartile is the median of the lower half. The upper quartile is the median of the bigger half. Okay? If you have an odd amount of numbers, we have 7 here, we don't count the median for the lower quartile and the upper quartile, okay? We don't count the very middle number. And remember, you have to order them all from least to greatest. Order from least to greatest. Very, 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 very important, okay? So let's move on. Let's look at an example, okay? Whoa, example 1. The heights of several students are shown. Make a box plot for the data. Okay, step 1. Order the data and find the needed values. They have all the heights right here. Like I said, step 1, very important, order the data. Order the data comes first, and then and find the needed values. So what are the needed values? The least value, the lower quartile, the median, the upper quartile, and the greatest value. Those are what we need to make our box plot, okay? So we list all of them out. We've got 54. We've got 56. We've got 56. Let's look. We've got 58. We put it down. We've got 58. We put it there. We've got 59. We put it there. We've got 60. we've got 61, 61, 62, 63, and then 65. So once we write all of them down in number order, we cross them all out, okay? So clearly, my least value is the one all the way to the left. My greatest value is all the way to the right, okay? I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 numbers. Therefore, the 6th and 7th are going to be my median. And then the 3rd and 4th will be my lower quartile. And then the 9th and 10th will be my upper quartile. So when we have two numbers, if I have two numbers like this, 56 and 58, what's in the middle of them? 57, okay? But if I have a number like this, to do it, I have to add them and then divide by 2, okay? Just like this, I have to add them and divide by 2. So when I add 59 plus 60 and then divide it by 2, I get 59.5. That's my median. And then when I add 61 plus 62 and then divide it by 2, I get 61. So 54 is my least value. My greatest value is 65. My median is 59.5. My upper quartile is 61.5. And my lower quartile is 57. Okay? So what we do is draw a segment connecting the least value to the lower quartile. Okay. So first things first, I get my least value, and then I go to 54. I draw a dot over 54. Okay? Then I look for 57. I draw a dot on 57. Okay? I look for 59.5. There's 59. I go in between 59 and 60. Draw a dot over that area. Same thing for 61.5. 61, in between 61 and 62. I draw my dot. Okay? And then my greatest value is 65. I go over 65. I make my dot. So I make a line to connect my least value and my lower quartile. Okay? And then I draw a line to connect my upper quartile to my greatest value. Not the best line in the world, but I'm trying my best. Okay. So now we draw a rectangle going through our lower quartile and our median. Okay? Then we draw another rectangle going through the upper quartile and the median. That is a box plot. Okay? It shows you the absolute least value of the numbers and the absolute greatest value of the numbers. Then it shows you the median, the lower quartile, and the upper. Does everybody understand? Watch that over again. You can watch it over again and watch me explain it. Okay, now that we got that down, let's try your turn. Okay? Here's our your turn. The daily high temperatures for some days last month are shown. Make a box plot of the data. Okay? I'm gonna give you some time to do this on your own. All right, that should be enough time. Okay, so first things first, I need to put them all in order and then find the values I need. Okay, so I've got, what is the lowest number? What's the lowest number? I've got 75. I've got 78. I've got 78. I've got 79. I've got, so I cross out 75. I cross out 78. I cross out 78. I cross out 79. I've got 80. I've got 83, 84, 85, 88, 89, 92, and 94. So I've got my LV, I've got my GV. So first things first, let's look. A, automatically out, okay? Because my least value is not 75. B, automatically out, okay? C, automatically out. My least value is not 86. So, oh my God, really? They made it that easy? E is the only logical answer, okay? Because this one is 74, 76, 78. So that is over 75, and that is the only possible answer that I can get. Okay? Use your brain. Think smarter, not harder. That is how we should work that out, okay? If there are multiple ones that have the same that have the least value and the greatest value, then you work into the median and the lower quartile and the upper quartile. Okay? So the median was 83.5, the lower quartile was 78.5, and the upper quartile was 88.5. Okay? So you would work that all out. Let's move on. Finding the interquartile range. A measure of spread is a single number that describes the spread of a data set. One measure of spread is the interquartile range. The interquartile range, IQR, is the difference of the upper quartile and the lower quartile. So range equals the biggest number, biggest number minus the smaller number. Okay, so now the interquartile range is just the upper quartile UQ minus lower quartile. Okay, so UQ minus LQ. So now the fun stuff is you have to find the upper quartile and lower quartile, and then you just subtract them. Okay? So difference of the upper and lower quartile. So the box plots, example 2, the box plots compare the ages of dancers in 2 different dance troupes. Okay? So my UQ upper quartile is 24. 24 for group A. My LQ, my lower quartile, LQ is 20. So my IQR or interquartile range, IQR for A equals 4 because 24 minus 20. So now group B, my UQ is 26. My LQ is in between 21 and 22. So I would say that's 21 and a half. 26, 21 and a half. When I subtract them, my IQR for B equals 4.5. Okay. So those are my interquartile ranges for A and B. Okay? Compare the IQRs. How do the IQRs describe the distribution of ages in each group? So since this is bigger, since B is bigger, it's slightly more spread out. Okay? When range is bigger, that means it's more spread out. When it's smaller, it means it's more compact. It's they're more together. Okay? There's not as much space in between them. Okay, let's move on. Okay, so your turn. The box plots compare the weekly earnings of two groups of the salespeople from different clothing stores. Find and compare the IQRs. Okay, pause. Your turn. Okay, let's get started. Upper quartile, lower quartile, upper quartile, lower quartile. Okay, so A. So I've got 1500, 1600, 1700, 1800. Lower quartile, 1000, 1100. Okay, and that equals 700. B. Okay, 15, 16, 17, 18, 19. That's in the middle, so 1850 minus um that is 1500, so 1400. And that is 450. So group A is 700, group B is 450. We've got C. Perfect. So if you got C, you nailed it. That's exactly how we work it out. So A is greater, so the salaries in the middle 50% for the group A are more spread out. So like I said, when it's greater, it's more spread out. If it's smaller, it's more compact. Small, compact, bigger, greater, more spread out. Okay? Moving on. So finding the range. Another measure that describes the spread of a set of data is the range. The range is the biggest of the is the difference of the greatest value and the least value in a set of data. Difference of the greatest value and the least value in a set of data. So I'm just taking the GV minus the LV. Okay? Greatest value minus least value. Okay? So let's go. So put the numbers in order or just look for the absolute smallest. So we've got 21 and then the biggest number is 39. 21 is the smallest, 31 is the biggest, okay? So all we're doing 39 minus 21 equals 18. 31 minus 21 equals 10. Okay? So the range of team A is 18 and the range of team B is 10. Okay? It's that easy. Find the range of each set of data. Which city's data has a greater range? So let's look. 76 is my smallest so far. So Miami equals minus 76. 91 looks like my highest. I don't see any higher than 91. So 91 minus 76 would be 15. And then, so it's either B or C. And then Chicago. I tried working that out. 31 seems to be my lowest. So 31. Let's look for the highest. 84. 84. Okay. So 4 minus 1 is 3. 8 minus 3 is 5. So our answer is letter B. And the range is way higher in Chicago. Okay, Chicago has the greater range. Okay, so that's it. If you're watching this video, you're a part of the class. See you next time, everybody.